Today I will be discussing about polarography. It is one of the most versatile analytical technique. Almost every element in one form or other, it can be detected and estimated by polarographic methods. Now if you see the diagram, it consists of electrolyzing the experimental solution using dropping mercury electrode, which will be acting as cathode, and a large pool of mercury or large calomel electrode that will be forming the anode. So here you can see in the diagram this mercury reservoir attached to capillary, from where the mercury it is dropping, it will be acting as cathode, whereas large pool of mercury that will be acting as anode. So this cathode, it is connected to the applied voltage negative terminal of the battery, and anode it is connected to the positive terminal of the battery. So through galvanometer you will be finding the current. As you can see in the diagram, the cathode it is connected to the negative terminal of the battery, as well as the anode it is connected to the positive terminal of the battery, and through the sliding contact S, the applied potential or voltage it can be varied by moving it along the potentiometer wire, that is AB. The galvanometer it will be indicating the current strength as it is present here, and the shunt S, which is connected across the terminal of the galvanometer, it will be allowing the sensitivity of the instrument. So experimental solution it is placed in the conical flask M, and this conical flask it will be bubbled with nitrogen gas to remove the dissolved oxygen, and the solution under study it is taken in this conical flask. So the potential will be so adjusted that it should be the reduction potential of the metal ion in the solution, and the metal ions they will be reduced to metal, and then it will be forming amalgam with mercury drops. Now the amalgam which is formed here, it will be dilute enough to be liquid, and as a result it can be removed from the electrode surface. So you have to maintain the height of the mercury in the reservoir to be constant. So new drop having same shape and size as the previous one, it will be falling. So succession of identical drops it falls from the capillary, and it will be giving rise to a cathode whose surface is reproducible. Metal ions which are present in the conical flask that will be moving towards the cathode due to electrostatic attraction, and there will be reduction of ions at the cathode, and that will cause decrease in the concentration of cations ions in the vicinity of cathode. So what will be established is a concentration gradient, it will be established between the depleted concentration. So this will be the current voltage graph. In polarography, actually the conditions they are so established that the movement of ions to the cathode that is controlled by the concentration gradient alone, and to neutralize the effect of potential gradient, a large excess of salt which is not reduced at a particular potential that will be added, which is known as the supporting electrolyte or KCl. It is supposed that the ions of indifferent electrolyte they will move to the cathode due to potential gradient, and they will accumulate there until their interaction it produces a potential equal in magnitude but opposite in sign. So here you can see this is the graph of current voltage relationship, and it is S-shaped graph which we call it as polarographic wave or polarogram. This can be divided into three parts. One is this line AB, then is BC, and then CD. So AB line, if you see, in polarography the conditions will be so established that movement of ions to the cathode that is controlled by the concentration gradient alone, and to neutralize the effect of the potential gradient, a large excess of salt which is not reduced at that particular potential that will be added, and we call it as supporting electrolyte KCl. It is supposed that the ions of indifferent electrolyte it will be moving towards the cathode due to potential gradient, and it will be accumulating there until there is interaction. That interaction it produces a potential equal in magnitude but opposite in sign to the applied potential. The metal ion conditions, the metal ions, they will be undergoing these conditions. They will be moving to the cathode under the influence of concentration gradient alone. Further, since the reducible ions, they migrate to the cathode, it will follow that the experimental solution, it has not to be stirred. So here you can see the graph of current voltage relationship. It is having 3 parts: AB, BC and CD. So this curve, it is a shaped curve and we call it as polarographic wave or polarogram. So in this graph you can see 3 regions: AB, BC and CD. So AB, if you see here, you can see the potential, it is insufficient to reduce the metal ions in the solution, and still small current is flowing. That is maybe due to some impurities which are present in the solution. So we call this current as residual current. Second is the point BC. You can see here point BC. After this potential, if you are applying further potential, so that will result in the reduction of metal ions will begin, and the current is going to increase sharply with the increasing applied potential. So this is what is known as the diffusion current, and it will be given by this formula. I will write it here. That is ID is equal to IL, that is the limiting current, minus IR, that is the residual current. At C you can see further increase in potential, there is no increase in the current. So this is the limiting current is reached, and further there will be no effect on the current. So the height of the curve, this one, that is known as the diffusion current, ID. So the potential at which the current I is equal to half of ID, that we will be calling as half wave potential, or E half it will be taken. So if of this curve, if you take the half, that will be E. So in this curve you can see this is a current voltage relationship, and this is the residual current, this is the diffusion current, and this is the limiting current. And somewhere here it will be what is called the half wave potential. There are certain limitation in polarography, that is mercury, it is very costly and poisonous, and electrodes, they do not function properly in presence of strong oxidizing agent in solution. And as you have seen, the dropping mercury electrode, it generate some current like residual current, migration current, kinetic current, and that will add on to errors, and it may be applied over potential 4 to minus 2.0. So above 4, if you see, mercury will get oxidized, and below minus 2 you will see hydrogen get reduced. So you have to be very careful while taking the reading. It is having advantages like the surface is smooth, reducible, and the electrode is continuously renewed, and the very high over voltage of hydrogen on mercury. It will be allowing the reduction of species which otherwise would have been difficult to be reduced. And many metal dissolve in mercury forming amalgam, and it has to be employed at a certain range of voltage with reference to you can say the saturated calomel electrode. And since the electrode is continuously renewed, a series of reducible species can be estimated in one solution. So these are the advantages of polarography.